I'm going to be going over how to do your homework, the homework over the Louis dot and covalent bonds and how they are related. Okay, so on each of these, on your homework, this is what you got a copy of. The first page is the actual homework that you'll need to be doing. Okay, the second page just has a breakdown of the metals, metalloids, and nonmetals. And then also it has the column numbers for the groups. Okay, so remember that group 1A has 1 valence electrons, 2 valence electrons, 3, 4, 5, 6, and 7 valence electrons. And then this last one is full. Remember, the noble gases have full valence electrons. Okay, they all have 8 except for helium. Okay, so something important to note too, and you'll see up here, there's a reminder. The number of valence electrons for each atom, the number that they need to be full is usually 8. Okay, the exceptions to those, you already knew hydrogen, because hydrogen only has an S level, so it can only have a maximum of 2. Okay, but there are 2 other elements that don't abide to being full at 8. Okay, and that is beryllium, which has a full valence electron or outer shell at 4 electrons, and then boron, which is considered a full outer shell at 6. Okay, so they only need 4 or 6 or 2 respectively for filling theirs in. Okay, so whenever you do your homework, just be aware you do have hydrogen, which only has 2, and then you do have beryllium, which only needs 4. So don't accidentally say that they need 8, okay, in order to be full. All right. So for the example of this, if I were to have a fluorine gas, which is F2, okay, the first thing we would need to do is determine the type of bond. Now, this is covalent practice, so all of these bonds are covalent. But just as kind of a reminder on your last activity, because it's a nonmetal mixing with a nonmetal, it is going to create a covalent bond between those two. Okay, so their electronegativity numbers are the same, so the difference between them would be 0, which is less than 2, because remember, 2 is the threshold between the differences in electronegativity to determine if it is a covalent bond. Okay, the next thing we would do is draw the Louis dot diagram for the individual atoms. So fluorine, if we find it here on the periodic table, is in column 7A, so it's going to have 7 valence electrons. So I drew out my 2 fluorines because it's F2, and then I put in the valence electrons. So there's 1, 2, 3, 4, 5, 6, and 7, and then I copied that here as well. Okay, remember, whenever you're filling it in, you put in the individual atoms first, then you start pairing them up. Okay, so for each fluorine, there's 1 unpaired electron, which is kind of the key for this bonding of covalence. Okay, so step number 3, you're going to find the number of bonds that can be formed. Okay, so remember, fluorine, it needs 8 valence electrons to be full because it's not hydrogen, it's not beryllium, and it's not boron. Okay. Currently, it only has 7 valence electrons. Okay, so the total number of valence electrons needed by both atoms for both of them to be happy would be 8 valence electrons plus 8 valence electrons, so 16. Okay, the total valence electrons that we currently have that are present in the atoms, we have 7 plus 7 is 14. Okay, so we can take the number of valence electrons needed minus the number of valence electrons present divided by 2 to get the number of bonds that we need. Okay, so if we take 16 minus 14, we would get 2, and then divide that by 2, we get 1. Okay, so this only needs 1. All right. You can also just look at the Louis dot structure and notice that there are, each has 1 set of unpaired electrons, so there's going to be 1 bond because they're basically going to pair up together. Okay. For step number 4, we're going to draw the atoms to show the full valence shell when sharing. Okay, so for this, we're going to drag and drop. Okay, and the important thing for doing this part is you want to make sure that the unpaired electron is towards the center. Okay, so I drew that one or diagram that one the normal way, but for this one, I'm going to flip it so that my unpaired electron is towards the middle. Okay, what we find is that here, these two can pair together. Okay, so that pairing together creates the bond. Okay, so remember with covalent bonds, they share electrons, so these would be the two that they share. Now, they don't only just share the two. I don't want you to be confused by this. That's kind of a common misconception, is that there's literally only 2 electrons that they share back and forth. It could be any of the other electrons, but at any given moment, they're sharing. One is sharing 1, and the other fluorine is sharing just 1 of theirs, okay? So then whenever we go to replace the shared electrons with a line, that's going to show the structural formula, which is what we need for your actual homework. So I'm just going to go ahead and copy the electrons and move them down. Okay, so we're going to replace the shared electrons with a line to show the bond. Okay, so here are my 2 electrons, and I'm going to replace them with a bar. Okay, so I'm going to go ahead and delete the 2 electrons. Okay, so each bar represents 2 electrons. Okay, and kind of the last step that you can do just to make sure that you've done everything correctly is to count the number of electrons that each atom has. Okay, or has access to. So remember that fluorine wants to have 8, so it has 1, 2, 3, 4, 5, 6, and then 7, 8, because it's sharing this. It has access to 2 via this line. Okay, same thing for this one, 2, 4, 6, and then 7 and 8. All right, this one is a little different because we are bonding 3 different atoms together. So we have water, H2O. Once again, oxygen and hydrogen are both nonmetals, and so it will be a covalent bond. So we're going to have 2 hydrogens and 1 oxygen in this molecule. Okay, so whenever we draw the Louis dot diagram, hydrogen, if we look, has 1 valence electron because it's in column 1A. So it's going to have 1 valence electron. Okay, and then if we go find oxygen, it is in column 6A, so it has 6 valence electrons. So I'm going to go ahead and fill in it. So 1, 2, 3, 4. Now I'm going to pair them up. 5 and 6. Okay. So now we're going to find the number of bonds that can be formed. So hydrogen needs 2 electrons to be full, because remember, it's one of the exceptions. It doesn't want 8, it only wants 2. Okay, so each of our hydrogens currently only has 1 valence electrons. Okay, oxygen needs 8 valence electrons to be full. It currently has 6. So if we're finding the total number of valence electrons needed, oxygen wants 8, and then both hydrogens want 2. So 8 plus 2 plus 2 is 12. And then the total number of valence electrons present in all atoms is, okay, so currently we have 6 plus 1 plus 1, so we have 8 currently. So 12 minus 8 divided by 2, it means we're going to have 2 bonds formed with this, okay? The important reason why we do it this way is because sometimes you're going to have atoms that are going to share more than just one pair of electrons, okay? It can form what is called a double bond or a triple bond, okay? So that's why you need to calculate the number of bonds, because you might have, for example, an oxygen and an oxygen, okay? And so oxygen has 6 and the other oxygen would have 6. They have 2 unpaired electrons, so they would actually have 2 bonds between them. So they would be a double bond for that covalent bonding. Okay, so I just wanted to make a quick note about that and why it's important to actually calculate out the number of bonds between the different atoms. Okay, so we're going to have 2 bonds. So drawing the atoms to show their full valence shell when sharing, okay? Also remember, during this part, you want to put the unpaired valence electron towards the center. So hydrogen only has 1 valence electron, so I'm going to put it towards the other atom. And same thing with this, the unpaired, I'm going to put towards the center or the other atom, okay? For oxygen, it has 6. I'm going to put the unpaired, if you remember, if we go back, the unpaired, they have 2 unpaired. So I'm going to do 1 unpaired towards this hydrogen, and then 1 unpaired towards this hydrogen, and then my paired ones are going to be kind of by themselves on the outside of the oxygen. Okay, so once again, here we're going to have a bond, and here we're going to have a bond, right, where they're going to be sharing these electrons. Okay, so whenever I go to draw my final one, I'm going to replace the paired electrons with a line showing that they're sharing these electrons. Okay, and then for the oxygen, it has 2 of its own paired electrons. Okay, so this would be the structural formula for water. Okay, once again, we can check. Hydrogen has 1, 2, access to 2 electrons. This hydrogen also has access to 2 electrons. And then the oxygen has 2, 4, 5, 6, 7, 8. So it is happy as well.